Hello everyone, this is Cuimei Zhang from South China Sea Institute of Oceanology. Thanks for offering me this chance to present our work. My talk today is about the breakup of the South China Sea continental margin. Ocean continental transition, we know bridges the unequivocal continental and the oceanic part. It preserves well the breakup process and the tectonomagmatic interactions. However, the process and the interactions are not straightforward. We learn from the archetype margins, the magma poor and the magma rich margins. They represent a distinct breakup process. Correspondingly, the crustal shape varies strikingly. In the magma poor margin, the crust wedges out and transits into exhumed mantle prior to the onset of the seafloor spreading. In the magma rich margin, it is magma controlled, and the magmatic addition impregnated the thin crust and formed a thick hybrid crust. But however, for a Pacific margin, the breakup process is much more complex than the two-end member, and the crustal shape would give us a diverse. So to map the OCT and evaluate the crustal shape in the OCT help us to address fundamental questions. Where and when the lithospheric breakup occurs, how the continental crust terminates, and the mutual seafloor spreading initiates, and what geological process lies behind the distinct shapes, and their interrelationship with the first magnetic anomaly. Our approach include the first is to define the crustal shape, the top basement and the morehole. The second is to interpret the content based on the geophysical and the geological data. The third is to differentiate the breakup process. Here are our definitions. OCT, we defined the domain between the unequivocal wedging continental crust and the box-shaped oceanic crust. Top basement is the top of seismic basement. Morehole here is a seismic morehole. Breakup could be crustal and lithospheric. This is the South China Sea map. South China Sea was opened over Mesozoic subduction of the Paleo-Pacific plate beneath the South China. These are the major events. The onset of the rifting started at 65 million years. However, it varies in different basins. And the seafloor spreading initiated at 32 million years and ceased at 16 million years. And the dashed blue rectangle shows the study area. It is covered by plenty of seismic reflection and reflection data, and together with the LDP drill hole in the center part. So this excellent data set make the South China Sea an exceptional area to study the breakup. So our study aims to make systematic mapping and to figure out the first order common characteristics of the OCT and along the overall northern margin. In the following, I just show a part of our study. We focus on the central part, that's the LDP drilling area. At this area, about six sites penetrated into the basement, and the drilling result and the post-cruise researches provide very good constraints for the interpretation, and we combine them with the seismic reflection data and the gravity and magnetic anomaly. Before interpretation, we first define the first order interfaces, including seafloor and the top basement. Here is the top basement here, and top basement has no age significance. The nature of the TB could be stratigraphic or tectonic or magmatic origin, and The third is the seismic moho. There are also three stratific horizons, including T80, it's a major thin rift unconformity, T70 breakup unconformity, and T60 early post-rift unconformity. Off we go. This is the section in the easternmost LW6. We can say from on this section, TB with present topography variation at site 5004. It was attested a detachment fault and overlaid and underlain by exhumed middle crust materials. The seismic moho shallowing from 9.5 to 8.2 second TWT, and the basement structure is characterized by the uptilting geometry, and they are truncated by TB. Somewhere we can see the strong reflections reminiscent of magmatic additions. And in the oceanic domain, the top basement is flat, parallel to the seismic moho. The seismic moho keeps constant depth at 5.8.5 second TWT. The basement consists of two layers. The upper one is subparallel reflection, and the lower one is deepening reflection. It is covered by the passive infill. We defined the OCT where the TB abruptly stepping down here, and the moho sharply rising here, and the outboard limit of OCT corresponds to the landward limit of this Penzos type oceanic crust. So this is our OCT. We already know that here the top basement equals to a detachment fault, and the whole basement present uptilting geometry. So in the OCT, the material below the top basement should come from much more deeper than here. So they may be very lower. They may be the lower crust, and the TB here should correspond to the detachment fault as well. This is another section. We can show TB present topography variation, and it's interesting that it steps down and marks by another top of basement. This here, this top basement we named top of new basement TMB. This is continuous towards the ocean. We marked TMB, which TMB was attested by site 5002 and recovered altered basalt, and at site 5000 recovered mob type composition. So TMB is of igneous origin. 6 moho shallowing from 10 to 8.5 second. Note that the basement is characterized by the downlapping geometry onto the moho. In the oceanic domain, it shows similar characteristics with section LW6. We define the OCT where TB here and the TMB overlapped, and the seaward limit of the OCT we use the same method. In this OCT, the crust thinned from 3 seconds sec to 0. The material was massively removed along the seismic moho with downlapping geometry. So this segment of seismic moho corresponds to a detachment fault that wedged out the crust. The thin crust in the OCT was strongly modified by the magmatic addition. And this is the last section, 1555, in the westernmost. TB shows variable topography, but lose distinct reflection here. This is TB. Here it disappeared within the basement. Seismic moho rise from the 10 to 8.5 and disappeared. and the basement structure shows downlapping geometry onto moho. In the oceanic part, the characteristics are much similar to those on the other two lines. We use the same method to define the limit of the OCT, same as the section LW7. The downlapping geometry indicates the detachment fault along the bottom of the crust as well, responsible for the crust thinning and wedging out in the OCT. This reflective interface has been drilled at 1499. It was attested to be the breakup unconformity. So the thin rift sequence and the up crust was interpreted existed below. And please note the location of the first magnetic anomaly. They lie on the three sections. They lie in the oceanic domain.
You're now at 11 minutes.
Okay, thank you. Then we mapped the OCT. This is the landward limit. This is the seaward limit. The seaward limit is consistent with the continental edge of the high gravity anomaly. Based on this interpretation, we know that on this section, the crust thinned along the top basement detachment fault. The honeying wall should have been removed and drifted to the southern margin. It reflects a lower plate setting during breakup. While on the other two sections, the detachment fault developed at the bottom of the crust, indicating the up plate setting. From the east to the west, the sharp variation of the plate polarity from lower plate to up plate occurred. We think a transfer fault must be located between the section LW6 and 155, accounting for this marginal segmentation. Finally, we establish a core complex type breakup. This is the final rifting stage. There is an inherited transfer fault. The polarity changes of the detachment fault changes in a short distance. During the breakup stage, somewhere like LW6, it is in the lower plate setting. Somewhere like 155 is in the up plate setting. The occurrence of the transfer room, that is the crustal inheritance, plays an important role on the marginal segmentation. If we go back to the questions we proposed at the beginning, here the crust either wedges out along the detachment fault at the top of the basement or at the bottom of the crust, or the crust was thinned or masked by a volcano. The latter case created very thick basement in the OCT. But in this study, we noticed that the gravity and the first magnetic anomaly are pretty consistent with the geological interpretation. However, this is not always the case in the northern margin. The northern west and the northern east South China Sea are very different from the central part in terms of the crustal shapes and the tectonomagmatic interaction. It remains a question how to integrate the geological and the geophysical interpretation, since there are many kinds of interpretation of the OCT, depending on their data set the author used. So this work will be continued with the aim to figure out the first order common characteristics of the OCT and the processes behind along the overall northern margin, as well to compare with the global OCT. Thank you.
Thank you very much, Cuimei. Are there any questions? You can either put your hand up or you can put something in the chat. In the meantime, I'm curious, those are quite variable lower crust, upper mantle structures that you see along those three lines. Do you have any seismic refraction data to support some of those mantle shear zones or those laccoliths that you interpret, or is it all based on reflection seismic?
there are 9 sections in the distal part. Only 4 only 4 are deep lines across from the distal margin to the oceanic part. So they are aimed. They are aimed for the LDP drilling site. So this is the condition, and there are also 3 striking lines along passing through the OCT. But the observations we got from in the dipping lines are very different on the striking lines.
I see Sasha's got his hand up.
Yeah, thanks a lot for this overview talk. I'm being interested in the unconformities that you mentioned, particularly the breakup unconformity. How large is the area that the unconformity can be mapped, and how sure can you be that it's actually related to breakup and not just to some coincidental other event?
It's a good question. I have to say that the breakup unconformity is not the most important unconformity in this area. It is for instance at the site ODP 184, the site 1184. There is no breakup unconformity. It's closing to it's neighboring our drilling area. So even in the distal part, there is no unconformity. That means that the breakup unconformity is we just interpret according to the first magnetic anomaly. But actually, I think in the wide rift margin, that is not necessary to observe widely distributed breakup unconformity.
Okay.
Thank you.
Thanks a lot.
And I had just one last question. You mentioned that transform fault to explain the kind of the flip in the polarity. What is, and you say it's due to some kind of inherited structure. What is the nature of that inherited structure?
It's hard to say. It's based on the flip of the plate polarity. But actually, we know in this area, we know in the Liwan, in the northern part, the Liwan sag was bordered by a transcurrent fault, transfer fault. So we think it may be contiguous to the southward, toward the south. So maybe link with our segmentation. It may be the origin. Thank you.